Okay, here's the video for section 10.1. You will definitely want a calculator for this. I will kind of go through it best I can. If you need some help, come see me. If you've been in class at all, you should recognize some of these terms. So 10.1 is applying counting principles and permutations. So we're going to talk about a few different things. The first one is what's called the fundamental counting principle. And in a fundamental counting principle, basically it just tells you how many ways something can occur. And the idea behind this is you're taking the number of ways each item can occur and you multiply them together. Okay, so for this first example, it talks about sandwiches. So a restaurant has 5 different breads, 4 different meats, 7 different cheeses. How many different sandwiches are possible? Now, if you go back to middle school, you guys may have done something like this. Here's my different breads. Okay, then I branch off of here with 4 meats. You know, and you go through there, and then off of each of those branches, you branch off with 7 cheeses. It's a pain. It takes forever. What this does is it allows you to ignore that tree diagram and just use the numbers. So 5 breads, 4 meats, 7 cheeses. We take those, we multiply them together. 5 times 4 is 20, times 7 is 140. So basically what this says is I can build 140 different sandwiches. There's your final answer. So it's taking the number of ways each thing can occur and multiplying them together. Now the second one says a Utah license plate has 3 letters and 3 numbers. How many plates are possible if all letters and numbers can repeat? So if you think about what this is saying, is I've got 6 spots on a Utah license plate. The first 3 are letters, the next 3 are numbers. Now what I can do is I can just fill in how many possible ways each of these can be filled. So with my first letter, I've got 26 possible letters that could fit in that spot. Now this can be a little confusing because only one is going to fit in that spot, but 26 could, so we have to use 26. For the second one, it could also be 26, and for the third one, it can also be 26 because it says the letters can repeat. Now for numbers, I've got 10 numbers, 0 through 9. I've got 10 numbers here, and I've got 10 numbers here. Now this is where you take them, and just like we saw in the last example, we're going to multiply them all together. So we go 26 times 26 times 26 times 10 times 10 times 10. That gives you 17,576,000 different license plates that are possible in the state of Utah. Okay, now look at part B. It says you now cannot repeat anything. How does that change? Well, my letter still starts at just 26. But the next one has to be 25 because one of those letters has already been used. And then I go to 24, and there's my letters. Okay, next thing I've got to do is I've got to figure out the numbers. So I've got 10 numbers here, but then all I'm going to have there 9, then all I'm going to have here are 8. And so I multiply those all together. Give me a second to do this in the calculator. You guys could work that out as well. And it gives you 11,232,000 license plates. So we've lost over 6 million license plates by just saying things cannot be repeated. That's the fundamental counting principle. So with this chapter, realize you're going to be multiplying a lot of things together. All right, the next thing we're going to look at are what are called permutations. Permutations are taking items and putting them in some order where the order actually matters. Okay, they have to be different. So I've got this ABC here. I can rewrite all of these in different orders. So ABC, ACB, CAB, CBA, okay, BAC, BCA. And they're all different, so there's 6 possibilities. What that does is it tells me in my first spot I had 3 possible letters. In the second spot I had 2. In the third spot I had 1, and I multiply those together, and that gives me 6. That's the idea of this factorial. Factorial is starting with a number and multiplying all the way down until you get to 1. So example 2 here says a TV news director has 8 stories he must use. How many ways can these stories be run? Well, I've got 8 stories. And each of these stories can fit into one spot. So in my first spot, I have 8 that I could use. The second spot has 7, third has 6, then 5, then 4, then 3, then 2, then 1. And as we already saw, when we multiply all those together, that works out to be the same as what we would refer to as 8 factorial. Now this factorial button is in your calculators. If you have a graphing calculator, you go to your math menu, scroll over to PRB, that stands for probability, and it's right there. And you type in 40,000, or sorry, 8 factorial equals 40,320. There's your final answer. All right, for B, this now changes things. It says we only can put in a lead, a second, and a closing story. So really I only have 3 spots. So it changes it. Now, how many could I put in that first spot? Well, I could put 8 in that first spot still. In the second spot, I could put 7. In the third spot, I put 6. Okay, so what that has done is limit my options. So now I take those, again, multiply them together. I've got 336. There's your final answer. Now what this leads to is an idea of permutation formulas. Okay, so the permutations of n objects taken r at a time follows this formula. You've got NPR. N is the total. Okay, so that n there is the total. The r is how many are being used. So in that previous example, I had 8 total stories, and I was using 3 of them. So this would be 8p3. Okay, you take them, you put them in the formula. So it's n factorial over n minus r factorial. So for this particular example, it would be 8 factorial over 8 minus 3 factorial, which is 5 factorial. And as you guys already saw, that's in your calculator, those factorials. You can use it that way. The NPR is also in your calculator. If at this point you still haven't learned how to use it, come see me and I'll show you. Okay, so example 3. How many ways can 4 raffle tickets be selected from 500 tickets if each wins a different prize? So our total is 500. That means your n would be 500. This is a permutation because order matters, different prizes, and we're using 4 of them. So it would be 500p4. And now you solve this. So it's n factorial over n minus r factorial. So 500 over 496 factorial. Those are both factorials. And you put this through your calculator. Now again, that NPR is in there, so it's in your math menu, your PRB. You go 500 NPR4, and this gets you 6.15. And then depending on the calculator, you're going to get something like that times 10 to the 10th. It's just a huge number. But what that tells you is how many ways those tickets can be drawn. It's not your chances of winning, it's how many ways they can be drawn. All right, what I want you guys to do is set this one up. So pause the video for a second, set it up, and then see what you end up with. You can solve this in your calculator if you want to, or you can do it by hand. Okay, so for this one, you've got n factorial, which is 8 factorial, over n minus r factorial. So that gives you 8 factorial over 3 factorial. Okay, again, calculator, that'll work it out for you. You get 6,720, and there you go. That's your answer. All right, finally, we've got something called distinguishable permutations. Now, if I were to take the word banana here and rewrite this, okay, just like that. Now, besides the fact that it's written by hand and it's a little bit sloppier, you can't tell me that there's a difference between those. But in fact, I have switched those 2 A's. Okay, those 2 A's are in different places, but it looks exactly the same. That's the idea behind this distinguishable permutations. We need things to look differently. Okay, and it follows this formula. So you start with n factorial. This is your total. Okay, down here, this is each letter, how many times it occurs, or each whatever. Okay, these don't have to be words, but in this case it is. Just how many times each thing occurs. So with this banana, there are 6 letters, so it would be 6 factorial. Okay, now we go to the denominator. The b happens once, so I would put 1 factorial. Now the key to this is the 1 doesn't do anything, okay, because it's 1 in the denominator. So you can ignore the 1s, but for this case I'll show it. The a's happen 3 times, so that's why I have 3 factorial. And then the n's happen twice. That's 2 factorial. So again, that denominator is how many times each of those values actually shows up. So you multiply this out. Now 6 factorial is 720. Okay, on the bottom, 3 factorial is 3 times 2. Okay, 2 factorial is 2. So 3 times 2 is 6, times 2 is 12. And 720 divided by 12, you work that out, it's going to give you 60. That's how many ways banana can be written that makes sense. All right, again, pause the video, try Mississippi, and come back and see how you did. Okay, so with Mississippi, you look at this, 2, 4, 8, there's 11 letters. So your numerator would be 11 factorial. Now M happens once, again, 1 doesn't do anything. The I happens 4 times. The S happens 4 times, and the P happens twice. Okay, so I take that and I figure it out. Now 11 factorial is this number here. Let's see, so that is 39,916,800. Okay, 4 factorial is 24. So you've got 24 here, you've got 24 here, and you have 2 there. So you go 24 times 24 times 2. That gives you 1152. Now divide those out, and you end up with 34,650. There's your final answer. So that's how many ways that Mississippi can be rewritten where they're all different. All right, so that is 10-1. If you have any questions, come and see me in class. Make sure you get this homework done.